Hello and welcome to Functions 1.1. What is a function? Okay, so today's lesson we're going to basically learn what a function is. And it's going to be kind of non-exciting, so sorry about the lesson. It's going to be just a lot of information, so it might be on the boring side. So I'll try to make this happen as fast as I can, but not too fast because I still want to make sure you understand everything that's going on. Okay, so let's see. Our first problem is going to be based on the story about Lilia, and she likes to use her cell phone like any kid these days, right? And she listens to music and checks Instagram. Yeah, no surprise there. Okay, so suppose she consistently uses 10 megabytes of data by the end of each day. Her data plan starts tracking how much data she uses from the beginning of the month. Okay, so basically it's asking us in the first question, how many total megabytes of data will Lilia use by the end of the day on August 5? Okay, so the things that we know are she uses 10 megabytes of data a day, and yeah, she's been tracking how much data she uses for the whole month since the beginning of the month. Okay, so let's see, it's August 5, so let's see, the number that we're gonna plug in to get our answer is gonna be a 5. Okay, and that 5 is going to interact with another number that's based on how much she uses per day. And when I make those two things interact with each other via multiplication, hopefully, yeah, then you're going to get some kind of a total for the month. So that's what we're going to base our formula on. So let's kind of talk out our formula and put it into, I guess, some kind of form that we can use. And it's going to look kind of like that. So our total, which is our total megabytes of data per day, is going to be 10 per day times the day of the month. Yeah. And when I do that, then I'm going to get basically total equals 10 times 5, which is 50. Okay, so after 5 days, she uses 50 megabytes of data. Yeah, not too bad. All right, so part B. Okay, so it says, oh, we're in a different day of the month. Now it's August 9. So does that mean we use a different formula? No, because it's still 10 megabytes of data per day. Yeah, we're just going to have a different input. We're going to have a different value that we're going to times by 10 because it's not August 5 anymore. It's August 9. Okay, so when I use the formula, the exact same one as up above, right? 10 per day times day of the month, we're going to go 10 times 9. Yeah, because it's August 9. And when I do that, we get 90. And don't forget the label because label is kind of important. So 90 megabytes. Okay. All right, so let's look at letter C. Okay, so it's a different day again, right? And now it's August 20. Our formula is still the same, still 10 megabytes of data per day times day of the month. So basically 10 times 20, and we're going to get 20 megabytes total for the month so far. Oh, sorry, not 20, 200 rather. Sorry, wrong word. 200 megabytes of data for the month so far. Okay. And letter D, this time it's just going to get kind of tricky because it's not really giving us a day of the month. It's giving us just a letter. Yeah, so it's telling us, well, what if it's the X day of the month? Yeah, like is there some kind of formula we can arrive at so that we can get these answers to various days in a month? So I kind of already made the formula. So I guess letter D was hinting at making some kind of formula, but we kind of made one in letter A already, right? Where you got the total equals 10 per day times day of the month. So that's kind of like our formula. So all we're going to do is we're not going to plug in 5 like in letter A. We're not going to plug in 9. We're not going to plug in 20. We're going to plug in X. Okay. So we're still going to use the exact same formula. We're just going to plug in X, and we're going to get 10X. Yeah, so it's kind of like our formula. So total equals 10X. Yeah, but we didn't really have to work too hard for that one because we kind of used the formula to get the other three answers anyway already. So yeah, not too bad. Okay. All right, so this is what a function basically does, or it is, right? You plug in something. Yeah, and when you plug it in, the rule or the formula or the pattern, yeah, does its thing. And you get some kind of an answer or an output. Yeah, so a good example that I always give to my students every year is working at a part-time job, right? So you can think of your input as your hours worked. Oops, that's not a pen. Okay, you can think of your input as hours worked. Hours worked. And you can think of your output as the money in your paycheck. And your formula is going to be basically how much you get paid per hour times the number of hours that you've worked. So I'll just call that, let's say your boss is generous and they give you $15 an hour. So your formula is going to be basically 15H because 15 times the number of hours you work is going to be how much basically your paycheck's going to almost be. Yeah. So Our input is hours worked, so let's pretend I work 10 hours. So that's my hours. Yeah, that's how long I work in that one particular pay period. And when I multiply it to 15, because that's how much I get paid per hour, my boss is generous, yeah, then you get your output of $150. Yeah, so that's pretty much a function that you can see in the real world, right? And hopefully you don't have this happen, where you work 10 hours and sometimes you get paid 150, and sometimes maybe you get paid 120, and maybe sometimes you get paid $500, right? You don't want to have that, right? Sometimes there's jobs that do that, right? Like waiter jobs, they have that because it depends on your tips. But right, for your first job, you kind of want to work on a job that's going to be kind of consistent, because yeah, you want to get paid an amount that you can count on, yeah, so that you can start saving for stuff that you want to buy for yourself. Okay, so if you do have a job like a waiter, which is dependent on tips, then you wouldn't really call it a function, because you could be working 10 hours, and every single day you work 10 hours, you're going to get different amount of money. So in that situation, that's not going to be a function. Yeah, but in this situation, because you're getting $15 an hour no matter what, we're going to call that a function, because it's something you can basically count on. Okay? All right, so let's move on. Next slide. So in the scenario of Lilia, yeah, what would be described as your input? Yeah, so what are we plugging in? What is the one thing that's changing from one problem to the next? And it's not going to be the amount of data that we used in the month so far. Yeah, but what are we using to actually get that different number? So what do we use to get 50 and 90 and 200 as our answers? Yeah, so what number do we use to get those three different answers or outputs? And hopefully you say, well, we had a different day of the month, right? And when you write your wording for what the input is in Lilia's scenario, hopefully you say something like this: the number of days rather, since the beginning of the month. Okay, and your output is going to be what your function gives or spits out as an answer after you plug in the 5, the 9, and the 20. Yeah, and we can describe that as some kind of a total. Yeah, the total number of megabytes we use so far. So yeah, I kind of write these answers on the slide in a different time. So sometimes I don't remember exactly what I write, but I kind of know exactly what it kind of says, right? So I know it's some kind of a total. I know we want to use a label of megabytes. Yeah, so as long as you have something like that in there, then your answer is good to go. Okay. All right, and keep in mind, yeah, this is a video, so if I ever go too fast, then just push pause. Yeah, if there's stuff on the screen that you got to write down, just push pause. Right, this is a video, so you can rewind, you can fast forward, you can do whatever you need to do. Okay, you can play it many times as you like, also, to understand what's going on, because yeah, like I said, I go sometimes pretty fast. Okay. All right, so next slide, definition of a function. So I kind of underlined the important parts for the definition of a function, so that if you ever have to write the definition of a function, then you kind of want to have these underlined portions, yeah, for each input, exactly one corresponding output. Okay, so if I ever tell you to write the definition of a function, you want to make sure you have these underlined portions in the definition. And if you don't have them, you kind of want to have wording that sounds kind of just like it. But don't change around the wording too much, because I have kids that do that in the past. And they change around the words too much, and all of a sudden the definition isn't there anymore. But in their eyes or in their brain, they're thinking, yeah, it's good to go. But in my brain, it's like, no. Yeah, that's not exactly what I want anymore. Okay, so you're better off just sticking with the words that you see here. Okay, so that's your definition of a function. All right, so next one. So it says, write your answers to problems 1A, 1B, 1C as ordered pairs. Okay, so you're going to think of your input as your X. So your day of the month is your input, and you're going to call that your X's. So in problem A, our input was 5. Yeah, and I plugged in 5, and I multiplied by 10, and the output or answer or Y value, if you want to call it that, is going to be 50. So your first ordered pair is going to be 5, 50. Okay, in letter B, it was August 9. Yeah, so we used the number 9 to get our output of 90. So that's our next ordered pair. Okay, in letter C, we had a day of the month with August 20. And we plug it in, multiply by 10, we get 200. So my 200 is my output. So there's my 3 ordered pairs. Okay, so problem 4 says move graph for answers. So yeah, like I said, I make these things in advance. Yeah, my handwriting's ugly, so I kind of want to type out as much as I can and do as much prep as I can. So all we got to do is basically plot these dots. So let's move this blank graph. So let's move it, and I have all the dots plotted. So 5, 50 is that one on the left. 9, 90 is the one in the middle, and 20, 200 is all the way on the right side up top. Yeah, so just plot those 3 dots as coordinates. So hopefully that you used to remember how to do that from your other math classes that you took before this class. Okay. Okay, number 5. Okay, so here it goes. It tells us write an equation again, except it's telling us to use x and y instead. Yeah, it's not telling us to use what I did in the previous slide with total and x. Yeah, actually x is still going to be in our answer, but we're not going to have the word total in our equation. So we're going to use x and y as our variables that are going to change from one scenario to the next. So x, hopefully you remember, is corresponding to input. So that's kind of like your days of your month. Okay, and y is going to be corresponding to output. So that's going to be your total for the month so far. Okay, so because I said total for the month so far, hopefully you say, oh yeah, then you're going to replace y in the beginning of your equation, because that's where the word total was. It was in the beginning of the equation. So y equals 10 times x. Okay, so y is your total, and that's going to be equal to the amount that you use per day times the day in a month. And that's going to be your equation that uses x and y in the equation, which is exactly what they wanted us to do. Okay? All right, next problem, or next page rather. Okay, so you can also display data as a table. Yeah, and tables are really good because they're really easy to read. Yeah, it's organized in a way that up and down they kind of match, right? So the 2 and the number right beneath it is going to correspond to each other. The 5 and the number right underneath it is going to correspond with each other. They're going to connect. They're going to belong to each other basically. Okay, so basically the top row is all my inputs, my x values, or the days of the month that have passed. And the bottom is going to be your outputs, or how much we use so far that month in total. Okay, so hopefully you guys pretty much just memorized the formula, and you basically know you just got to multiply it by 10. So when you do that, you're going to get all these numbers, right? Times by 10 for each of these x values, you get 20, 50, 70, 90, 140, 200, 280. Okay, so that's pretty cut and dry. All right. So number 7 says, does every input value of x have only one output value y? So this is basically the definition of a function. Yeah, this is basically the definition of function. So it's basically saying, is this a function or not? Is the scenario that's being mapped out in a scenario about Lilia using data every day, yeah, and the total amount that she has used for the month so far, is this representative of a function? Yeah. So another way you can read and interpret this question is, when you look at all these x's, do these x's have just one y value? Or do some of these x's have two y values for the one single x? So that may sound confusing. So let me give you an example. So let's say I had a scenario where it says 2 days have passed so far, and Lilia used 20 megabytes of data. And let's say we have another scenario where Lilia has 2 days have passed basically, and now she used 25 megabytes of data for 2 days. So we have one scenario where 2 days have passed, she has 20 megabytes of data total used so far. And in another scenario, we have 2 days have passed, and she has 25 megabytes of data used so far. So we have 2, 20 and 2, 25. So that would be an example of no. Yeah, we don't have one input value x with only one output value y. Yeah, that scenario would be one input value x with two output value y. So that would make no as our answer. Yeah, but in this case, let's see, do we have any repeating x values, right? Because if I see repeating x values, then it's going to pretty much mean that I have two y values. So do I only see one occurrence of x in this whole entire row? And one occurrence of 5, one occurrence of 7, and one occurrence of 9, 14, 20, and 20. Do I see only one occurrence of each of these x values? And if I do, that's pretty much a very good sign that the data that's being shown to me right now is a function, because I only have one x value with one corresponding y value. Okay, so hopefully when I uncover this box right below, it's going to say, yeah, this happens, right? I have one x and one y that corresponds to it. Yeah, so let's see. Yeah, it does say yes. And what is the reason? There are no repeating x values. So every input or x value has only one corresponding output or y value. Okay, so let's look at an alternate scenario where it might describe kind of like what I was talking about earlier, where you have a single x value that has multiple y values corresponding to it. Okay, so let's look at this alternate scenario. So I have -5. Is there only one single occurrence of -5 in the entire x row? Yeah, I mean, we have a 5, but that's not a -5, so that's not the same thing. So let's look at the next x value, -3. Do I only have one -3 in the entire row? Yeah. Okay, so what about 0? Do I have any other zeros in the x row? No. Ooh, let's look at the x value 1. I have a x value 1 that has a output or y value -6. And right next door I have a x value 1 with a y value of 2. So I have an x value, right? I have one x value with two outputs or y values. Okay, does that correspond or does that match definition of a function? Right? Definition of a function says I got one x value and one corresponding y value. Okay, so in this particular scenario, would this be a function? And this would be no, yeah, because my x value has two y values. So hopefully you say no, because there are repeating x values. My x is repeat, and because my x is repeat, the input x equals 1 has two outputs, -6 and 2. So this would not be a function. This would pretty much say no to the question asked in number 7. Does every input value of x have only one output value of y? Yeah, and 7, like I said earlier, basically says, is this a function? Wording the question this way, does every input value of x have only one output value? That's pretty much saying, is this a function, yes or no? Okay, and this would be a no because there's two x values called x equals 1 that have y equals -6 and y equals 2. So that's pretty much, yeah, doing what this question is saying not to do, which is one x value, one y value. Okay, so I know this alternate scenario is not in your packet, so you might want to just copy this down on the side so that you guys can see a scenario where no is the answer to this question. And the one on the left side is going to be a output value, right, or a table of values that have yes as the answer to that question. Okay, all right, let's move on. Okay, so let's see. This problem right here, 8a, as well as 8b, right after this. Yeah, this is going to pretty much be a problem that you're going to see all year long on every single end of the quarter exam. Yeah, so please make sure you guys know this question and how to answer it really well. Okay, so when I teach my kids, I want my students to always answer these types of questions in 3 pieces or 3 steps. First, you're going to say yes or no, whether it's a function or not. So you're going to say yes, this is a function, or no, this is not a function. Okay, and in step 2, you're gonna recite the definition of the function. So remember I said earlier in a couple of slides back that you want to make sure you take note of the underlying parts of the definition of a function that I had in that other slide. Yeah, and you're going to get real good at it because you're going to write the definition of a function every single time you do a problem like this. Yeah, so do you think you're going to be writing the definition only once? No, you're going to be writing it many, many times. Yeah, like I said, this problem is going to appear on every single end of the quarter exam. Okay, and part 3 is supply evidence. Yeah, give evidence that supports why it's a yes or a no. Okay, you can't just say yes or no and just do like eeny, meeny, miny, mo. Yeah, when you say yes or no, you're gonna back it up with evidence, so I know that you actually understand why it's yes or no. Because yeah, anybody can go eeny, meeny, miny, mo. It's a 50-50 chance, yes or no, right? 50-50. Yeah. So the difference between a kid that understands is gonna pretty much give evidence of why yes or no is the correct response. Okay, so let's look at our data. So let's look at all our x values. Do I see only one of each x value? Do I see another 61 in this entire row, or another 67, or another 63, or another 71, or another 70, or another 62? So do I see any x values repeat? Because if I have x values that repeat, then I look at the y values, and if they're different numbers, then pretty much I don't have a function. So the first thing you want to look at when you approach a table of values is, does any x value repeat? So let's look. Does any x value repeat? Is there any repeat of any of these x values? And it's going to be kind of hard to see because we're mean. Yeah, we didn't make these numbers in ascending order. Yeah, we put them all different order. So it's kind of difficult to keep track of the numbers. Yeah. So do you see any that repeat? And hopefully you say no, none of them repeat. So what does that mean if none of them repeat? Does that mean it's a yes or does that mean it's a no? Okay, well, let's see what I have. And hopefully you say, yeah, this is a function because none of them repeat. Okay, so let's look at step 2, which is definition. Okay, so for every input, there can only be one output. So here's the thing that gets me every year when this problem comes up. Yeah, when I get kids that do these problems and they answer questions in quizzes or exams or whatever, yeah, sometimes they put different definitions for every single time they do one of these problems. And I'm like, why are you putting two different definitions for the exact same kind of problem? Yeah. And you're like, I don't know. And we're like, yeah, well, isn't the definition supposed to be the same no matter what? Yeah. So please get it in your brain, yeah, that when you start writing the definition for step 2, don't start writing a different definition every single time you come to a problem like this, because that should not happen. It should be the same definition every single time. Yeah. So for every input, there can only be one output. So why do you think I emphasize the word only? I put it in red and I made it all caps. Yeah. And the reason is, well, when I start grading the quizzes and exams and stuff like that, that's the one key word that kids always leave out. Yeah, they always write, for every input there can be one output. Yeah, they forget the word only. And if you forget the word only, then game over. Yeah, your definition is wrong. You need to have the word only in your definition. And if you don't have it, like I said, game over. Your definition is wrong. Okay? And that's the one word that kids always forget every year. All right? So please don't forget it. All right? Okay, step 3. So what is the proof that proves, yeah, that backs up this yes answer? Okay, so like I said earlier, when we figured out that this was a yes, what do we notice about the inputs or the height? What do we notice? That none of them did what? And hopefully you say none of them repeated. And if none of them repeat, then that's why it's a yes. So when I write my evidence, look at what I did. Look at what I wrote. Okay, there are no repeating inputs. Yeah, so whenever you see a yes answer for a function, I better see no repeating inputs in your evidence. Okay, so yes is always going to have no repeating inputs in the evidence answer. Yeah, so there are no repeating inputs, which in this case is our row of height values. So every input has only one output value or output, yeah, which is the weight. Yeah, notice how I kind of just regurgitated the definition and the evidence. So you don't really have to have regurgitation of the definition in there, but main thing is you have the no repeating input statement in there though. Okay, so don't forget about that. Okay. Okay, so let's look at 8b. So this is going to be your first problem you do for homework. So just remember now, when you do 8b for homework, you're going to have yes or no. Okay. You're going to have definition and you're going to have evidence statement. So don't forget to have those 3 things. Okay. All right, so let's look at the next slide. It's a vertical line test. Okay, so the vertical line test also tests to see if something is a function. Yeah, it's gonna pretty much be a test that you run that's gonna help you to say yes or no. Yes, this is a function, or no, it's not. Okay, but we're not gonna run a vertical line test on a table. Okay, a vertical line test is usually done on graphs. Okay, and when I run a vertical line test on graphs, it's gonna help me to figure out whether it's a yes or a no. Okay, so please don't confuse vertical line tests with tables. They don't correspond to each other. Yeah, you use vertical line tests when you're evaluating graphs. Okay, keep that difference in mind. Okay, and look at what we have in our very next slide. We have graphs. And we're going to use a vertical line test to evaluate it. So I'm going to say 9A for homework, but I'm going to do 9B. Okay, so this blue line that I have hitting the graph, yeah, this sidewards parabola, is going to be my vertical line. And I'm testing to see if this sidewards parabola is a function or not. Okay, so you got to remember, your x value is your input and your y value is your output. So let me ask you a question. What is the x value of this blue line? Okay, so this blue line has all the same x values because it's a vertical line. So what is the x value for this entire blue line? And hopefully you say your x value of this blue line is 3. Hopefully that's what you guys came up with. The x value of this blue line is 3. Okay, so that's your input. Yeah, your input is x equals 3. Okay, so let's look at what this vertical line does to the graph. It intersects it, it hits it, it makes contact with the vertical line. And where does it make contact? It makes contact at these two blue dots. Yeah, these 2 blue dots represent where the vertical line hits the sidewards parabola. Okay, so what is the y value of this top blue dot where it makes contact? And hopefully you say this top y value is y equals 2. Okay, so we got an x of 3 and a y of 2 when this vertical line makes contact with the sidewards parabola. Okay, and we have another intersection point. We have another part where the vertical line makes contact with the sidewards parabola. And my x value is still 3, right? Because every single x value on this blue line is 3. But my y value is now -2. Oops, come on, let's write -2. Okay, so we have a single x value 3 giving two different output values of y, 2 and -2. So what does that tell you basically about yes or no, it's a function or not? Do we have a function? And hopefully you say no, this is not a function. Okay, and the reason why it's not a function is, like I said, listen to your definition. Every input can only have one output. And in this scenario, our one input 3 has two outputs, 2 and -2. So hopefully you say no is your answer. Yeah, and in step 2, for every input, there can only be one output. So notice how there's your definition again. Yeah, did it change from the previous problem that I did? No, it didn't. It's the exact same definition. So whether you're dealing with evaluating a graph, whether you're dealing with evaluating a table, your definition is not going to change based on whether you're evaluating a table or a graph. It's the same definition every single time. Okay? But as far as your evidence, that's going to be different because we don't evaluate tables with vertical line tests. We evaluate graphs with the vertical line test. So when I evaluated this graph with the vertical line test, it fails. So this graph fails the vertical line test. Okay, and let's point the person that's looking at this evidence in the right direction. So where is it failing? Like what is the things we're seeing so that we know it failed? Because if we don't know why it fails, then when I run it on my own without this video, then we're going to be like, oh, I don't know how to identify when it fails. What do I see when it fails? What do I see when it passes? Yeah, so that's where these dots come in, right? So you see these two dots? That's where the vertical line hits the sidewards parabola. Yeah, so at input value x equals 3, which is kind of like what I talked about when I explained the graph in the vertical line test, there are two outputs, y is 2 and y is -2. Okay, so this kind of cite evidence that shows me that you know what a vertical line test, like why it fails. Yeah, like what is the signs that are going to tell you, yep, this thing fails. Yeah, so just make sure you have the evidence that backs up why you know it fails or why you know it passes. Okay, all right, so let's look at our next slide. Okay, so definition of domain and range. Very important words. You're going to see this pretty much all year long. Yeah, so hopefully you guys can remember the definition of domain and range. And like I said, good thing this is a video. So if you ever have to refresh your memory on domain and range, just come back to this video. Yeah, and just replay it. Okay, so domain is going to be your inputs. Range is going to be your outputs. Yeah, and it's going to pretty much describe what every single input can be for the scenario we're in, and what every single output can be for the scenario we're in. Okay, and on the bottom here it says how you're going to write domain and range when you have to write them as part of your answers, which is going to be something we do this upcoming year. We're going to start writing domain and range in certain scenarios, in certain situations. So you want to make sure you know how to write domain and range, okay, as far as how to make it appear on your paper. Okay, so and let's use the scenario of Lilia again. Okay, in domain, hopefully you remember that domain is your input, domain is your x values, and x values in this problem was going to be the day of the month. Yeah, so that we can use that day of the month to figure out how much total has been used so far this month. So the domain that we can use are the days of the month in the month of August. So hopefully you know how much days are in August, and hopefully you know that there are 31 days in August. Okay, and if you know that, then you're going to say, oh, okay, my domain values can be 1, 2, 3, 4, 5, with the dot, dot, dot showing that it's going to continue this pattern of increasing by 1, all the way till we get to 31. Okay, so you start the pattern, you pretty much show the person that's looking at your domain what the pattern looks like. So you're increasing by 1, 1, 2, 3, 4, 5. And you don't want to write out all 31 numbers because that's kind of humbug. So you use dot, dot, dot to show that this pattern is going to keep on going. And then you want to show when the end is going to occur. Yeah, because we can't just make it go on forever, because does August have like 60 days in August? No, it only has 31. So we have to cap it, we have to limit it, or we have to stop at 31. Okay, so that's going to be your domain. And make sure you start off with the letter X, because X corresponds to domain. So X colon, and then the numbers that X can be, so 1 to 31. Yeah. Okay, so range. Range is going to be your output. Range is going to be your Y values. Range is going to be the total that we used so far that month. Okay, so hopefully you know that if it's day 1, we use 10, day 2 we have 20, day 3 is 30, day 4 is 40, and so on and so forth. So we're going to have those kind of numbers. Okay, so our range is going to be 10, 20, 30, 40, 50, dot, 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 because that pattern is going to continue, 290, 300, 310. Yeah, and that's going to be your range. And make sure you start off with Y, colon, because you want to make sure the person that's looking at these range values know that these numbers are going to be used in conjunction or combination with Y. Okay, so make sure you make that distinction. All right. Okay, next one. So let's see. Write the definition. Write the domain and range for Lilia's scenario using a written description. Okay, so we know that domain is the day of the month, so we're going to pretty much probably have something in along those lines. So let's see exactly what we have. So X is going to be every integer. So make sure you have the word integer because we can't use decimals or fractions. So every integer from 1 to 31 inclusive. And inclusive means you can use 1 and 31 as part of your domain, as part of your X values. Okay, and range, okay, we're gonna be using the 10, 20, 30, 40, 50. So hopefully you remember, oh, those are like multiples of 10. Hopefully that term is still in your brain from other classes that probably taught you guys about multiples. So you're gonna have Y because you want to identify that range corresponds to Y, and it's gonna be multiples of 10. From 10 to 320, I'm sorry, 10 to 310 inclusive. So like I said, inclusive is going to include 10 and 310 as part of your Y values. Okay, so let's see. So I did a lot of problems, so you're probably thinking, we only have like 2 problems for homework. Sorry about that, you have a little more. Okay, so your homework is going to be this page, 1A, and then 1B, 1C. So please make sure that when you guys do 1B and 1C, I know it doesn't say to do this in the instructions, but I want you to start getting used to the 1, 2, 3 steps where you say yes or no, you write the definition, you give your evidence. So with these tables, I want you to tell me if this is a function or not. So I know it's not in the instructions to do this, but trust me, the more practice you get at this, the easier it's going to be to start getting these problems correct. Yeah, because like I said, these kind of problems that ask you to evaluate numbers, inputs and outputs, and evaluate whether it's a function or not is going to be a problem you're going to see all year long. It's never going to go away, I can promise you that. Okay, so you want to get good at it, so it's best to practice when we have the time. So let's practice the 1, 2, 3 steps for B and C. You don't have to practice it for A, yeah, B and C, and I think you also have to practice the 3 steps for D. Okay, so good luck on this assignment, and I'll see you in class. Bye-bye.